All right, welcome back everyone. So this is going to be part two. We're going to be learning about properties of logarithmic functions. So the general equation is going to be y equals a times log base b, and then we have brackets k times x minus d plus c. So in this example, just like for exponential functions, you have a base number. For log functions, you also have a base value. And remember, the equation y equals log base b, x is the inverse of the exponential function y equals b to the power of x. So exponential functions and logarithmic functions are related in that they're inverses of one another. Here's four examples that you should know, kind of similar to the four examples of exponential functions, where you have k is greater than 0 and b greater than 1. And this example is y equals log base 2 x. And that is shown here in this red graph here. It kind of starts down here, goes up, 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 and grows. So that's example 1. Example 2, we have k is greater than 0, and b is between 0 and 1. So a log with a base value that is a fraction or a decimal. And that looks like this green graph here, and it's growing down, so it's decreasing. 3, when k is less than 0, and b is greater than 1, so k is negative. An example of that is log base 2, and brackets negative x. And this function is going like this, and it's going down, so it's also decreasing. And finally, example 4, where k is negative or less than 0, and b is between 0 and 1. So y equals log 0.5 negative x. And that is shown by this yellow graph, and it's kind of increasing. It's going up, 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 up. One thing you'll notice that when it comes to log functions, there are no horizontal asymptotes, but there are vertical asymptotes. That's because in our exponential function, we had horizontal asymptotes. And it's kind of like you could say like the opposite when it comes to inverse functions. So instead of horizontal asymptotes, logarithmic functions have vertical asymptotes. And here's a summary. So some key features: vertical asymptote starts at x equals 0 and can be shifted by the d value. So remember, horizontal asymptote for exponential function was the c value. For log functions, it's a vertical asymptote, and it is your d value, and it's x equals your d value. X-intercept instead of y-intercept, which is set y equals 0 and then solve, and then pick one other point. Usually you can just choose y equals 1 and then solve for that for your x value. And yeah, let's do an example now. Let's see. Okay. So here we have f of x is equal to negative 4 log base 3 x plus 2, and g of x is equal to log base 3 and in brackets negative and in brackets x plus 2 close bracket minus 4. The key important thing is to find out what's your base function. And your base function is basically your function without any transformations, without your a, k, d, and c values, and it just has your b value, your base number. In this case, the base number is 3. So my base function is going to be y equals log base 3 x. And what are some values that we can use when it comes to this? Well, remember, vertical asymptote is something that we need to know, and that is just your d value. And remember, vertical asymptote, the equation for a vertical line is written as x equals, that's x equals 0. And we're just going to pick negative 1, 0, and 1 for our base values. And if you're not sure how to calculate this, the way to do this is to choose a y value. Let's say negative 1 is equal to log base 3 x. And hopefully you should know how to do this from lesson 1 and 2 of this unit. You can raise both sides by the base number. So you can do 3 to the power of negative 1 is equal to x. And 3 to the power of negative 1 is just 1 over 3. So here we have 0.33. 0 is another example. So here we have 0 is equal to log base 3x. We just raise everything to power, not to the power, sorry, raise everything with base value of 3. And then it's to the power of 0 in this case. That's just 1. Because anything to the power of 0 is 1. And the last one, 1 is equal to log base 3x. That's just 3 to the power of 1, which is 3. So here we have enough points now to be able to draw a nice, generic curve. And we're going to do the exact same thing for our transformed functions, except with our transformed functions, we can just use our mapping notation. Remember mapping notation, x over k plus d, ay plus c. So what's my a value? In this case, a value is -4. K value, it's 1. That's the only number that's being multiplied. D value, there is no D value, or it's 0. And my C value is 2. So in this case, x is just x, because there is no K and D values. And AY plus C, so that's -4y plus 2. So my x values don't change since there are no transformations that are affecting the horizontal axis there. And y values. So -1, substitute that in. -1 times -4, that's 4. 4 plus 2 is 6. 0, so that's going to be 2. And then 1, that's going to be -2. So there we go. Oh, I probably should have chosen a different color for that. That's fine. Choose blue for this. In this example, my a value is the number in front of log. There is no number there. Technically, it's 1, so a is technically 1. But it doesn't really affect the transformation. My k value is -1 because of the negative sign. And then what's in the bracket is my d value. Remember, d value is -2 in this case, and that's my c value. So this is just going to be x over -1, which is just -x minus 2. And a is 1, so it's just going to be y minus 4. Let's go back to our values here. So 0.33 times it by negative, and then minus 2, so that's -2.33. Now we have 1, so -1 minus 2, that's -3, and we have 3, so that's going to be -5, and then we have our vertical asymptote. Remember, the vertical asymptote is just my d value. What is my d value here? It is -2, so x is equal to -2. As for my y value, -1 minus 4, that's -5. 0 minus 4, that's -4. And 1 minus 4 is -3. So there we have it. We have completed our table of values. Once you've done that, we can graph our functions. So let's graph. Okay, I think that's good. All right. So the first things first, we should always graph our asymptotes. So we're gonna do f of x in red, and the vertical asymptote is at x equals 0. So that's just this right here. All right, and we have 0.33 and 6. So x value is 0.33, so that's here. And y value is 6, so that's around here. Then we have x value of 1 and y value of 2. And then we have x value of 3 and y value of -2 here. So in case some of you are tempted to draw something like this, please don't, because this function doesn't have a horizontal asymptote. It does have a vertical asymptote, so this part will go like this. But these points will keep growing, probably growing a bit faster than that, maybe like that. But yeah, something along those lines. Like there you go. And that is it. As for blue, or g of x, we have our vertical asymptote at x equals -2. So x equals -2 is here. And let's extend that. And let's see, we have -2.33 for my x value and -5 for my y. So -2.33 and -5, so that's here. We have -3 and -4, so -3 and -4, that's here. We have -5 and -3, -5 and -3, that is here. So what's happening here? It's got to go down like this. It's got to be like that, and that's got to go up like that. And then our parent function, which is in black, 0.33, or sorry, our vertical asymptote as x equals 0, it's already there. So 0.33 and -1, 0.33 and -1, 1 and 0, and 3 and 1. So it's going something like this. There you go. So these are my 3 graphs of my log functions.